In this video, we are going to demo how to automate the deployment of an edge data center using Dell VxRail and Ansible. Organizations are investing in use cases that require extracting more value from their data, but more and more data is being generated outside core data centers and cloud, and much of it needs to be analyzed in real time. As a result, customers need to deploy and manage edge computing across hundreds of locations. The challenge is to do so in a cost-effective manner. Dell VxRail is a popular solution for many edge use cases, as it extends its efficient operational model and simple lifecycle management from the core data center to the edge. For day one operations, Ansible can automate the deployment of a full edge data center end-to-end, from VxRail hardware to the applications, without having to be on site. In this demo, we use a single VM running Ansible to configure a 3-node VxRail cluster in 3 steps. Ansible will first configure the VxRail. Then, it will copy and register a Linux VM template. Finally, it will deploy and configure all the VMs described in a data center template. Organizations can have different data center templates depending on the use case, for example, a retail branch or a warehouse, or simply based on size. In our example, we have templates for 2 data center sizes, big and small. Here we can see what the big template looks like. An application named Portal will be deployed. It will consist of 2 virtual machines with the CPU, RAM, storage, and network settings shown in here. The VMs will be configured as Apache web servers by including the relevant Ansible playbook. The template contains 7 applications at the moment. Let's add a new application to this template. This solution provides 8 sample application playbooks. They implement the best practices for security and performance provided by the relevant SMEs, such as web admins, DBAs, or data scientists. The list includes applications that are commonplace nowadays in edge deployments, such as machine learning and Internet of Things. This will deploy 2 file servers, will upload files required on site, and it will export them via NFS. On the Ansible VM, we start the playbook, and we request the big template. From this point, the whole process is automated. The VxRail configuration starts. Ansible uses the VxRail modules from this GitHub page. We can see the progress in this log file. The dry run task completes in 7 minutes. Then the installation task starts. In the log file, you can see what step is being performed and the percentage of completion. This is the lengthiest part of the process. In our example, it took 46 minutes to complete. At the end of this step, we have a fully configured VxRail and a virtual center. The playbook moves on to the next step without the need for any human interaction. It has discovered the name of the newly created vSAN data store, and it starts copying the template files. Once the copying is over, it registers the template in vCenter. Now the playbook starts provisioning all the VMs with the required virtual hardware. A total of 13 virtual machines are provisioned, including the 2 NFS virtual machines we added earlier. Ansible ensures all the VMs are up and reachable before moving on. Finally, it configures every VM with the relevant application playbook. This step took 5 minutes. The full process is now complete, and Ansible has performed 260 tasks. In the host view, we see the 3 VxRail nodes. The VxRail plugin has been registered. With the plugin, operations for the edge infrastructure are vastly simplified as everything is managed through vCenter, including lifecycle management and even cluster expansion. We also get visibility of the underlying hardware, including the physical location. And we can see the overall system health and configure remote support. Let's take a look at the VMs that have been built. The portal website is up and running. MySQL was installed and a password was added. The CMDB database was also successfully created. The IoT application should be already actively collecting data and writing it to the InfluxDB time series database. Let's log into Grafana to visualize it. We can see a configured data source that points to the InfluxDB virtual machine. And the data source is functioning properly. In dashboards, we see the building environment monitor dashboard was created automatically. New data is being ingested every 5 seconds. The NFS VM is exporting an NFS share, and the site relevant files were correctly uploaded. A custom Python environment was created on the machine learning virtual machines, and the necessary Python packages were installed. In this demo, we have shown how we can automate the deployment of an edge data center using Dell VxRail and Ansible. Thanks for watching.